Want to move on to our next speaker too. It's got another topic of concrete and innovations. We're getting a lot of good details on our infrastructure here, and Dan DeGraff is definitely an expert in infrastructure as executive director of Michigan's Concrete Association and materials. He's got a great presentation for us on concrete sustainability and how we're doing in Michigan and what's happening nationwide. So Dan, could you introduce us to your topic?
Thank you. We've got some new words that are coming around. Sustainability is becoming part of our vernacular now in the Midwest. EPDs and GWP, EPDs, environmental product declarations, and GWP, global warming potential. All of these are going to become common over the next few years. But Michigan, I'm pleased to report, is a leader in concrete sustainability. And when we talk about sustainability, we talk about engineering, economics, and environmental factors. But in the early 2000s, we started to really look into concrete from an engineering perspective. We optimized aggregate gradations. We looked at our aggregate quality requirements. We reduced the cement content. We made it mandatory that supplemental cements be used, which helps densify and keeps the water out of the concrete. That will help on the bridge deck issue as well. And we started this in the paving world back in early 2004 is when a lot of this stuff got introduced. We added it to the bridges in 2014. The really neat thing is that this also reduced our cost. Because we took out the most expensive ingredient, which was cement, as much as we could. And environmentally, the CO2 that we are including in our product comes through the cement fraction itself. So it turns out to be a win-win for all of us. But to start with, when we talk about concrete and we look at all of the CO2 and energy that's tied up with products in our industry, with concrete, lime, clay, steel, glass, timber, asphalt. Concrete really is the low end of the spectrum as far as CO2 output and energy input. We have a position where if we can reduce the carbon output from our concrete, we can make a significant savings. If we use other building materials, we start at a much higher baseline, a much higher global warming potential. So we are working hard to improve our position as it is right now. EPDs, environmental product declarations, they're sold as like you buy food at the grocery store with a warning, with a label that tells you of all the ingredients. That's partially true. The basic unit of an EPD is a global warming potential, which is in kilograms of CO2 per cubic meter of concrete. It is an international number, so most of us like to convert to cubic yards. But it's based on carbon inputs from the source raw material and transportation of that material to a batch plant or a concrete plant site, and then also the energy used to produce the concrete at the plant. But it stops calculating the global warming potential or the CO2 potential at that point. An EPD for the initial EPD for a plant is pretty expensive. The initial EPD ranges from $5,000 to $7,000 to get a plant set up. They have to go through the process of calculating all of the cost, the fuel cost, the generator or power grid that's used to make the plant. But once your plant is set up, you can generate multiple EPDs after that. Every mix design will have a different EPD if you really get down to it. And they can do that for a very minor cost. It's the initial setup where the expense is. But the other important thing to think about here is as we move forward, we need to see what happens during the life of that structure or pavement. EPDs are based on what's known as a product category rule. Each industry, whether you're glass, wood, timber, asphalt, concrete, got together amongst themselves individually and developed product category rules. Everybody wanted to be measured the way they wanted to be measured. So as a DOT, you're going to see EPDs from different materials. They are not all apples. They're apples, oranges, grapes, tangerines. You can't compare one EPD to another and say this product is better or worse based on an EPD. And EPDs are in transition. They're updated. How they measure things. There's some changes that are happening as we speak. So this is a little chart about what some of the inputs. So we start at the left side of the page where we extract raw materials from the ground. In Michigan, many of our aggregates come from the quarries up north. They're put on ships and brought down to docks, and then we're shipped to the concrete plants. That is cradle to gate, and that's what an EPD deals with currently. But we also know that the life that structure is put in over the next 30, 40, 50, 60, 70, 80 years, depending if it's a building or a road structure, or where most of the carbon impact is going to happen. If you have a building that you have to heat and air condition, the heating bills and the air conditioning amounts to probably more like 90% of the carbon input, rather than the small portion that goes into construction. And in addition, during the end of life, or during its life, concrete reabsorbs carbon dioxide. CO2 is reabsorbed into concrete. So any surface concrete that's exposed, like a road or a column in a building or a wall, will soak up carbon during its life, maybe 15, 20% of the carbon that was released when it was constructed comes back into that product during its life. Remember, some people along I-75 a few years ago, there was a mayor of Flint had this huge pile of recycled concrete. That was actually, in an environmental world, one of the best things you could have, because that was one of the best carbon uptake receptors that there ever was. So while that sat in that big pile, that pile of recycled concrete really absorbed a lot of CO2. So it was environmentally a super site. Concrete EPDs, and on all the EPDs, you need to have a program operator and a practitioner, but a third party. So with our EPDs in concrete, NSF, now that's not the National Science Foundation that TRB is part of, or what you saw Dr. Fauci work for with the COVID, but that is NSF. It is an independent third-party body that was formed in 1944 out of the University of Michigan, and it dealt with food safety and setting up safety standards for small restaurants. And they are one of the leaders still today in testing and keeping people safe in the food sciences and health professions. So they are the body that we look to help us keep track of what we're doing here. GSA, Government Services Administration, for all the building work, any building that's built with federal money, they've got standards now, and Federal Highways and FAA are also developing standards as well that people will be required to follow. When we make cement, we make the clinker, we automatically, as we heat the limestone, it gives off CO2. That's a byproduct. So we put out about almost half a ton of CO2 for every ton of cement, just in heating the raw material. The fuel that we burn also adds to the CO2 that goes into the air, and that adds to it. So the numbers that the inefficient wet system was what was in Dundee, and the plant in Dundee, Michigan. That plant closed a few years ago, and it won't be reopened because it was a very inefficient process, as opposed to the Charlevoix and Alpena plants, which are much closer to the European average for output. So what the cement industry is doing is looking through, and across the bottom of the page here, you'll see that in 1972, where there's a little over a ton of CO2 emitted for every ton of cement. 2019, it's down to about 0.85. And the goal for the cement industry is to get that number down to 0.67. And they're doing it through alternative fuels. Some are switching from coal to natural gas. Others are, different formulations. But the effort is to change the industry to reduce that output. And here's the one mathematical formula I'm going to show you today. It's a kilogram per cubic meter of carbon converted in pounds per cubic yard. So typically, if we call it 0.9 tons of carbon for every ton of cement, there's a formula we can use to calculate. And I've done this with, we did a project down in Ann Arbor 2 years ago. The GAS target is 385 kilograms per cubic meter. With our standard 6-ec mix, we were around 300 just from the cement input, not the other pieces. But when we go to well-graded use of supplemental cements towards the bottom of the page, the net combined with the type 1L cement we're using now, we're down to 168 pounds or kilograms per cubic meter, which is a 44% reduction with what we're doing currently. So Michigan has been a very strong leader in getting us to this point. Most EPDs are from plants on the coast, California and New York and up in New England. At the time that we put this slide together, I got it from a guy that used it in the spring. There was 40,000 EPDs out there. Today, I believe the number is double that. So there's a large volume of these being generated. Illinois and Minnesota and Ohio up a couple of years ago here, that they were the only place that had it. There were only 360 EPDs from the Midwest. By the way, most other industries total have less than 1,000 EPDs from the other industries, but concrete's got quite a few. They are tied to a specific plant location, and one of the goals is one of the modifications they're trying to do to this, the programming is to allow for the portable batch plants to be used and have an EPD produced for a portable batch plant. That's the next phase of EPDs. Just a reminder that an EPD is the material manufacturers off to the left, and there's the state agency really needs to develop a life cycle assessment for people to plug their EPDs into, which allows you to look at the cost of transporting to the project site, construction, and then the use phase, which is where a majority of the carbon dioxide is produced through the vehicles driving on the roads or the people living in the buildings. And then also the end of life. What do? Do you crush it up? Do you reuse it? All of those to go together in our total carbon footprint. Coming back to what we started with, sustainability, engineering, we reduce cement, we optimize the design, we use recycled materials, we improve the fuel mileage for trucks driving on concrete roads, environmental, the use of supplemental cements, the reduced carbon footprint, optimize pavement designs, reduce truck emissions, and then economic, lower costs and improved long-term performance has a very big benefit there. So with that, we thank you, and as more specifications require the EPDs, the Michigan producers will be able to generate those for you going forward.
Thanks so much, Dan. Appreciate you introducing us to environmental product declarations, global warming potential, and giving us a state of state here with our concrete and where we fit in compared to the rest of the nation. I think that's a really informative session as we look forward to innovating here with our materials. Very helpful to learn the ins and outs of the industry. So appreciate all your good work you've done with the Michigan Concrete Association, helping support MDOT and our infrastructure. If there are questions, go ahead and continue putting those in the chat. We are having some difficulty with some lag on that, but keep putting them in. Hopefully we'll get answers to you. If you don't get answers today, make sure you connect with the people that presented. I'm sure they've got interest in communicating with you and sharing more with you about their innovation.